Bob measured the heights of 63 students. After analysis, he conjectured that the height h of the students could be modeled by a normal distribution with mean 166.5 centimeters and standard deviation 5 centimeters. A. Based on this assumption, estimate the number of these students whose height is at least 170 centimeters. A random variable h, the height of the students, is distributed normally with parameters. Mean it's 166.5, and here must be variance. Variance is standard deviation squared, so we write 5 squared. And let's find the probability that the height of one student is at least 170 centimeters. So let's find probability that x is greater or equal than 170. So we consider distributions, normal CDF, and lower bound is 170, upper plus infinity, for example 10,000, mu is 166.5, sigma standard deviation is 5, and we get the next result, 0.242 to 3 significant figures. And to get the expected number of students, you can guess that it's just total number of students multiplied by the corresponding probability. But if it's needed to show more clearly, we say and write the next, that let y be a random variable, the number of students with the height at least 170 centimeters, and y is distributed binomially with parameters 63 and probability. And the probability, which is the answer for the previous question, and expected value for binomial, it's MP. This formula is given in a data booklet, hence the expected value of the students with the height at least 170 centimeters becomes 63 multiplied by 0.242, and it is equal to, we just multiply by 63, and we should take an exact value here because it's not the final answer, and we can see that it's 15.2 to 3 significant figures, or actually it may be taken to 3 significant figures. And in general, expected value may be decimal. It doesn't matter that we consider students or any other objects which are measured in whole numbers, because expected value is theoretical mean, theoretical expected value, and it may be considered as decimal if we consider students, but it's required estimate the number of these students, so it means we need round to the whole number, and we can write that approximately 15 students. The next. Later Bob noticed that the tape he had used to measure the heights was faulty, as it started at the 5 centimeter mark and not at the 0 mark. B. What are the correct values of the mean and variance of the distribution of the heights of these students? So actual values are 5 centimeters less. So we can consider x be a random variable, actual height of the students, and x is h minus 5, and it's a linear transformation of two variables, and it is given in a data booklet. It is given in terms of y, it's new variable, and x, it's the previous variable, so it is given as y is ax plus minus b, and expected value of y is a expected value of x plus minus b, and the variance of y, it's a squared variance of x. So here it becomes expected value of x, it's just expected value of h minus 5, which is 166.5 minus 5 is 161.5 centimeters, and the new variance of x, it's just variance of h, and it's 5 squared or 25. Variance doesn't change because variance or standard deviation describes relative distances between points, and if all points are shifted by the same value, their relative distances remain the same, and hence variance doesn't change. So x is distributed normally, so a new distribution becomes normal with parameters 161.5 and variance is 25. And that's all for this question.